Hello friends, welcome to the online lecture series of St. Andrews Institute of Technology and Management, Gurugram. Myself Satendra Vats, Assistant Professor in Etce department. Our today's topic is generation of frequency modulated waves and their demodulations. So this is a part of unit 2nd of communication system in Etce 4th semester. So first of all we will see the generation of narrowband FMs. As we have already seen, frequency modulation consists of it can be narrowband or it can be wideband. In narrowband FM, the modulation index beta was less than 1. So beta is less than 1 in case of narrowband FM generation. Okay, so as we can see, this is the standard equation of FM frequency modulated wave, which we have already seen in the last lecture. This is the amplitude AC, this is the carrier frequency FC, this is the message signal MT, and KF is the sensitivity constant. So if we apply the formula of cos A plus B, which is nothing but cos A into cos B minus sin A into sin B, so we would get an equation which looks like this. Okay, AC cos 2 pi FCT multiply cos of 2 pi KF integral of MT dt minus this function. So we can simply expand our equation using the cosine function cos A plus B. So for narrowband FM, this is the condition, that is 2 pi KF integral of MT should be less than equal to 1. So it must tends to 0, that is it is a quantity which can be almost 0, that is like 0.01. so if we put this value 0, if we put this 2 pi kf mt almost 0 in this equation, we would get this equation, because cos theta, that is cos 0 would be 1. If this is 0, so cos 0 would be 1, and sin 0, as we all know, sin 0 is 0. So sin theta would be theta, for theta tends to 0. So this is how we can get this equation of the narrowband FM. You must remember this condition, because only when we apply this condition we can get the narrowband FM equation. So this is the final equation consisting of two terms, that is the carrier, and it will also consist of two sidebands. Okay, so let's see how we can generate it. This is the block diagram of a narrowband FM modulator. So in this is the message signal MT. We have applied it to the integrator to get the integral of MT. This is the carrier frequency which can be generated using a local oscillator. We have fitted it to a phase shifter which provides a 90-degree phase shift. Then the signal becomes AC sin 2 pi FCT, and then these message signal and this phase shifted carrier signal is applied it to the product modulator, which would give this term, and we will multiply 2 pi kf there. Then this signal is fed to the summer and the carrier frequency as well, so it will add these two terms and we would get the product, the narrowband FM wave. So this is how we can generate using this block diagram or this circuit narrowband FM modulated wave. So summer block has two inputs, that is one from the product modulator and one is the carrier frequency signal. So it will add both of them to provide us the narrowband FM. Now let's see the methods of wideband FM. In wideband FM, beta is greater than 1 and it will consist of infinite sidebands. So there are two methods for it, direct method and Indirect method. In direct method, the voltage control oscillator is used to generate the wideband FM. VCO, that is the voltage controlled oscillator, produces an output whose frequency is proportional to the input signal voltage, which is the basic definition of the frequency modulation. Nothing new in it. So we can see the block diagram. This is a basic block diagram of a wideband FM generation direct method. So in this voltage controlled oscillator is here. We would apply the signal, modulating signal, okay, that is MT, and it would provide us the wideband FM. So this voltage controlled oscillator basically consists of a tank circuit, which can be a LC circuit. This is L, this is C naught, which would provide the carrier frequency FC, that is FC is equal to 1 upon 2 pi under root LC naught. So this is how this circuit would provide the FC, that is this part, as the instantaneous frequency is nothing but a term added in the carrier frequency, or which depend on the modulating signal. So this carrier frequency is generated by this LC circuit, and this circuit is this LC circuit, LC naught, is connecting to a, it can be a, it is basically called a reactance modulator. It is a reactance modulator which would generate the frequency modulation, and this is the direct method. Reactance modulation is the direct method of frequency modulated wave generation. Okay, so we will apply our input MT to the terminals of this modulator, which can be a reverse bias PN junction diode. So this will generate a frequency, instantaneous frequency, which would be Fi is equal to Fc, which we have already know, 1 upon 2 pi under root LC plus Kf MT. So this circuit would provide this instantaneous frequency which we require in the frequency modulated wave generation. Okay, so this is how this voltage oscillator controlled oscillator works. It would provide us the wideband FM. We have already know that for this instantaneous frequency should be equal to the Fc plus Kf MT, where Kf is the sensitivity and this is MT is the modulating signal or the message signal. So this is how it can be generated wideband. And the second one is indirect method. It is called indirect method because we are generating a wideband FM wave indirectly. First we would generate a narrowband FM wave, and then using a frequency multiplier we would increase the bandwidth of the generated wave. So hence in this way this is a indirect method because we are generating narrowband FM first. So in this we are using a narrowband FM modulator, which we have already seen. We would provide the modulating and the carrier frequency, and then it would provide a narrowband FM wave. So if it provides us a frequency of let's say Fi, then if we multiply it there are number of multipliers can be there in frequency multiplier to increase the generated frequency. So it would be multiplied, and hence it would increase the bandwidth of the generated wave. So in first stage the narrowband FM will be generated using narrowband FM modulator, and then as the beta is less than 1, modulation index is less than 1 in a narrowband, so it is applied to the input of frequency multiplier, which produces the wideband FM with the frequency n times of narrowband FM. So this is an indirect method. Now let's see some of the demodulations method, FM demodulation. So first is frequency discrimination method. So we have already generated this signal. This is a frequency modulated wave, AC cosine of 2 pi fct plus 2 pi kf integral of mt dt. So if I differentiate it with respect to time, I will get this function. Okay, or to get rid of this minus sign here, I can put minus sine theta is equal to sine theta minus 180 degree. Okay, in this signal I would use this minus sine theta is equal to sine theta minus 180. So the equation would look like something like this. I have differentiated it and applied this sine function, so it would become this. Okay, so if I rearrange the equation, I would get this equation, as I have taken AC 2 pi fc common from this bracket. So inside the bracket what remains is 1 plus kf upon fc into mt, and the rest of the function remains same. So this is the function we would get. Okay, so in this equation equation resembles the amplitude modulation wave. Okay, amplitude term resembles envelope of AM wave. So this term resembles the AM modulated wave. Okay, so how we can demodulate it? We have generated this signal. Let's see in the block diagram. I have provided the differentiated the ST function which we have just seen. ST, that is the frequency modulated wave. It is differentiated and the d st by dt would be produced here, and this function is applied to the envelope detector. As we can see in the equation, it resembles a amplitude wave equation. So using the envelope detector we can get the our message signal or the modulating signal MT. Our requirement is the modulating signal MT, hence we can recover it from the envelope of the AM wave. Okay, differentiator is used to convert the FM wave into a combination of AM and FM wave. This differentiator is used to convert the FM into a combination of AM wave and FM wave. So it converts the frequency variation of FM wave into the corresponding voltage, that is amplitude variation in AM wave, and using an envelope detector we can get the modulating signal, that is a message signal, because envelope detector produces the demodulated output of an AM wave, which is nothing but the modulating or the message signal MT. So at this output we would get MT, which is we need to receive at the receiver end. So now second method is phase discrimination method. So its block diagram consists of a multiplier and the low pass filter and the VCO. So here we have the multiplier, okay, which would receive the modulated wave, frequency modulated wave. Then a local oscillator is there which would produce the same carrier frequency as we have used at the transmitter end. Okay, so this multiplier would multiply both the signal, that is the frequency modulated wave, and this VT. Okay, so VCO produces an output signal VT whose frequency is proportional to the input signal. So this is the demodulated output, that is the MT or DT. So this would VCO would produce frequency proportional to the input signal. Okay, initially when we don't have anything at the output, that is DT or MT is equal to 0, what would we get at the VT? The VCO adjusted to produce an output signal having a carrier frequency. So it would be a signal with the carrier frequency and a phase shift of 90 degree. Okay, so it would be a signal having the same frequency Fc, but the phase is shifted 90 degree. Okay, so when FM wave ST and the VCO output VT are applied to the input of this multiplier, that is here we have applied the input ST and the VCO output VT. Multiplier produces an output having a higher frequency and a low frequency component, which is passed through a low pass filter to get the low frequency modulated signal. So this multiplier would produce two frequencies. Okay, one is a high frequency and one is low frequency, and we all of us know that our modulating signal or the message signal is a low frequency signal as compared to the high frequency carrier. So we need to get the low frequency signal, that is the modulating signal at the output. So that is why we would use a low pass filter. We would use a low pass filter in the end to get the demodulated output. So this is the phase discrimination method of the FM demodulation. Okay, so this is it for the lecture. Thank you very much.